All right, ladies and gentlemen, so we are going to be working on the Gravity on Other Planets lab. Now, this isn't a very difficult lab, but it does require you to do math. So again, you are going to show all of your calculations, okay? You have to show your calculations. It's going to be 20% or 20 points out of 40. If you do not have your calculations, you're going to lose half credit, okay? So the first thing you have done at this point is created a cover page, right? You've added it to your Notability. It's the first page. You are going to take a selfie with this picture here that says Gravity on Other Planets. That's what your selfie is going to be. That goes on the cover page. Got it? Good. Fantastic. All right. So here's a little background information. All right. We've talked about it before, but your weight is based on your mass and the gravitational pull of wherever you are. So on Earth, it's 9.81 meters per second squared. Okay, that's the gravity on Earth. So the formula that we use is weight is equal to mass times gravity. Makes sense, because it doesn't matter where you go, your mass is not going to change, right? The amount of space you take up does not change. But your
Ms.
weight
Gonzalez,
will. What's up?
I'm sorry, I joined late.
Okay, so we are just working on the lab, so make sure you download it.
Okay.
All right, so here's how you are going to first figure out what your mass is, okay? So what you're going to do is, nobody else is looking at this but me, okay? Nobody's looking at this. I'm not even going to look. I'm going to just put down a number here that I was in, like, high school, right? So you put your mass in pounds here.
Miss J, are you on or does it have to be entirely typed?
For the calculations, you can write it, but I want you to type up everything else.
Okay, thanks.
Okay.
Ms. Gonzalez?
Entirely in case you have that issue again of uploading. Stefan, what's up?
Did you take attendance yet or no?
No. I'm doing this first.
Okay.
Okay. All right. So now we have my weight in, or my mass in pounds from when I was in high school, right? And then according to this, it says convert your mass into kilograms by dividing your mass by 2.2 kilograms per pound. So I'm going to take the 101 pounds and divide it by 2.2 kilograms per pound. Okay, so now pounds cancels, and I am left with, now remember, you're doing this based on your current weight the last time you got on the scale. Again, nobody's judging, nobody's looking at this. Okay, so do not feel embarrassed. Some people get embarrassed by their weight. I don't know why. Please do not. Okay, so the answer here is going to be 45 for me and me only, 0.91 kilograms. Did everybody get their mass in kilograms? Yes, no, maybe.
Yeah.
Okay, now we're at step 3 here. It says, using the value obtained above, calculate your weight on Earth using the formula listed above. So this is going to be, I'm going to write it down here because there's just more room. This is when you take W equals M times G, right? My mass, you're going to put your mass here. Okay, and the gravity on Earth is 9.81 meters per second squared. So my answer is going to be 450.37. That's my personal weight in kilograms times meters per second squared. Okay, at this point, everyone should have that much done. All right. Is anybody still doing the math for this?
Yeah.
Okay, I'll give you a minute. Let me know when you're done.
Does this actually go in our lab, or is it just an example?
No, this is my numbers. You're following along and using your numbers. So,
Oh, okay.
so let's say you were 107 pounds. You would calculate your mass in kilograms here and then calculate your weight in kilograms times meters per second squared. Okay? Make sure that your original mass was in pounds. There are some of you that already go by kilograms. I don't want you to do that. I want you to convert it to pounds first.
Ms. Gonzalez,
What's up?
is the work for C W equals mg?
The W equals mg? Yes.
Thank you.
No problem. Okay. Once you have that done, okay, you are going to go to the website. The website looks like this. Okay, did everybody get here? Okay. You are going to put the answer to C in this box here, 450.37. And then click calculate. Right? So it should be a very large number that you added into this. Okay? Right? You will see that not only do you have the planets, but you have the moons of Jupiter, you have the stars, okay? Your weight is going to be different on each of these, okay? So then you're going to go back to your chart. Okay, and you are going to record the values down here, right? So it starts with Earth, and my weight on Earth is 450 point, what did I say, 450.37 kilograms times meters per second squared. Okay, you are going to copy this down for each individual one. So you're going to type in here, all right, you're going to type in Mercury, right? And then you're going to type in on this side. For me personally, it was 170.2 kilograms times meters.
Do we have to type it?
Yes, it's a chart, so of course you have to type it. The only thing you can write are the whatchamacallit, are the calculations.
Is there a dot between kg and m/s?
Yep, it's a multiplication symbol. All right, so 170.2 kilograms per meters times meters per second squared. All right, I'm not going to copy all of them down because I want to get to the calculations, right? And I'm just going to use Mercury.
Do we round our weight?
No, leave it as is.
Because mine is 107.9.
So leave it as is.
Okay, thank you.
Okay, now here are the calculations. Okay? You're going to start with Mercury. Okay? Of course, you guys need to make sure you label it so that I know what we're looking at, what planet you're looking at. Okay? You need to calculate for gravity on that planet. You're searching for the gravity on that planet. Okay? Now again, all of the calculations, right, I put on Google Classroom and a breakdown of what all of this is, okay, just in case. All right, so in order to find this, let's just return this down here, right? Here's the generic version of what you are actually doing, okay? You need to do W equals mg. Okay, this is just the generic so that you can see exactly what you're doing. Okay, you're going to take this value from the website or from the chart. Okay, your m, because it's your mass, which does not change, is your mass in kilograms from step 1, and you're looking for G. Okay, so for example, all right, I'm doing this as with my numbers and my numbers only. You're doing this based on your numbers. All right, so for Mercury, from my chart, it's 170.2. All right, so it's W equals mg, right? Or I can write it as G is equal to W over M, right? 'Cause all I did was solve for it. So my weight on Mercury was 170, what do we say, point 2 kilograms times meters per second squared, divided by my mass from step 1, which is 45.91 kilograms, because you need it to be, right? You need it to be in kilograms. If this is not in kilograms, then they will not, units do not cancel, and you are not left with the correct units. Okay? You want your units to cancel so that your gravity is in meters per second squared. 0.2 divided by 45.91 equals. So the gravity on Mercury should be, and everybody's gravity should be the same. 3.71 approximately meters per 7 squared, because you're going to round to 2 decimal places unless otherwise told. When you did this, did everybody get 3.71 meters per second squared? Because you're doing this with me, correct?
Yep.
Yes.
Okay, Riley, you got it?
Yeah.
Okay, Jessica, you got it. Trish, you got it. Everybody else, are you okay? Because I'm going to do the last calculation with Mercury, and then I'm going to let you guys go and do this. Did everybody get 3.71?
I didn't get 3.71.
Who is that? Maddie. Okay, so what numbers do you have? What's your
I got. Wait, what number?
What's your weight on Mercury?
219.1.
219.1. Okay, and then what was your mass in kilograms?
579.67.
Nope. That's not yours. You have to look here. That's not your mass. That you're looking at your weight. Your mass in kilograms is the answer to B here.
Oh, okay. I took the wrong number.
Yeah, that number you're going to use for every single calculation that you solve for gravity. Okay? So that's the one you have to use. So now, Maddie, when you put that number in, do you get 3.71?
Yeah.
Okay, then you're doing it correct. Okay, so now I'm going to do Mercury's for this one. Okay, this one you are doing a ratio. All right, and the gravity for Earth, like we said, is 9.81 meters per second squared. Okay, so for Mercury, right, notice I'm labeling it. I'm expecting you guys to label each one of them. Okay, I'm looking for the ratio of the gravity of Mercury and the gravity of Earth. So what I found was, or we all should have found, is the gravity for Mercury is 3.71 meters per second squared, right? The gravity on Earth is 9.81 meters per second squared. So meters per second squared cancels, and I am left with 3.71 divided by 9.81. That is not possible. Well, 3.71 divided by 9.81. That's better. Okay, so the ratio should be 0.38. There are no units in this. Okay, because they cancel, so there are no units. Okay, and you're going to round to the nearest hundredth again. Okay, that's the whole lab, right? Because you're gonna answer these questions, and that's the entire lab. So most of the lab is going to be math. Okay, so that's going to be the hard part. Since you guys are allowed to write out the calculations, you may need to add, like I would definitely need to add like 5 or 6 pages, because look how big my handwriting is, right? I know there's a way that you guys know how to do it where you can shrink it down. That's fine if you want to do that. But otherwise, you can add in pages on Notability here, okay, so that you have all of the calculations
Wait, Ms. Gonzalez?
in one spot. What's up, Trish?
You said you can round to the nearest hundredth, right, or tenth?
Yeah, 2 decimal places unless otherwise told. I'm telling you to do
Okay, thank you.
places. Okay. If you guys want to check with each other, that you're getting the correct answers, that's fine. But remember, your numbers are your numbers. So nobody's numbers are going to be exactly the same except for the answers, how you get to that point. Okay, and I'm okay with you guys talking throughout this entire lab. I expect you to be talking during this entire lab. Okay, so that's pretty much the whole lab. That's it. It's just a lot of math.
Miss Gonzalez.
Give me one.